Welcome, everyone. This is Terry Erzman with Percona. I'm the Chief Marketing Officer here. I'd like to cover a little background housekeeping before we start with the presentation today. If you can hear me, if you would please raise your hand in the GoToWebinar screen, I'd appreciate it. Let's make sure we've got good sound. Very good. See hands going up. Thank you. We will make a recording of today's webinar, and we'll send you a link for that recording as soon as it's available. So if you'd like to share this, please feel free to do so. We'll also put a copy of today's slides up on the recording page. You can take another look at those as well. I am very pleased today to welcome Jay Jansen, one of our senior MySQL consultants here at Percona, and Jay will be presenting on migrating to XtraDB Cluster. If you have questions during the presentation, please enter them in the questions panel in the GoToWebinar control screen, and we'll answer as many of those as we can at the end of the presentation. Jay, I hand it over to you.
All right, thanks a lot, Terry. So welcome, everybody. I wanted to give a talk that really didn't, as I've been spending time working on XtraDB Cluster, getting to know it, getting familiar with it, I was really more interested in the operational aspects of how do we get this thing working, what did it take to go from standard MySQL to XtraDB Cluster. And so basically I wanted to write this talk and give this talk to really give sort of an operational heads up, like here's sort of the basic things you need to know to get into it. So as such, this talk isn't about a lot of the internals, although some of that is important for operational concerns. But it's really going to be focusing more on just the nuts and bolts. So here's what you need to do to get going with XtraDB Cluster. So that being said, I do feel we need to spend a little bit of time and get people, just make sure everybody's on the same page about what XtraDB Cluster is and what it isn't. So XtraDB Cluster is really simply Percona Server 5.5 plus the Galera Synchronous Replication add-on that is open source and written by the good guys over at Codership. And really, when I think about what this is, in my mind, it's a cluster of MySQL nodes, and not to be confused with the MySQL cluster product, which is really the NDB storage engine with some MySQL nodes attached to it, and that engine, forms a cluster. This is truly a cluster of MySQL nodes that are all talking to each other and replicating directly to each other. So all of the nodes in XtraDB Cluster have all the data all of the time. And so this is synchronous replication, all the data is going everywhere, and really you've just got all these independent nodes or things that look like independent nodes talking to each other. All of the nodes are readable and writable in the cluster, so you can connect your applications wherever you want to go. You can read and write off of any node in the cluster. There are some limitations to that I'll talk about, but in principle, this is how you can set it up. So if you look at the diagram, we have, as an example, the cluster here, 3 nodes in our cluster. They're all synchronously replicating to each other. We have various clients in different locations, all connecting to different nodes in the cluster to do reads and writes at the same time. So once we have this cluster formed, the established cluster is responsible for synchronizing new nodes. So as you bring new nodes into the cluster, it's responsible for getting it cloned and getting it ready. It's responsible for handling node failures. So when the node goes down or has some kind of network issue or whatever, the cluster, its job is to deal with that for you. It handles node resynchronization. So if a node is offline for a while and it comes back online, the cluster will fix itself. And it also has baked into it split brain protection. So if we have any network partitioning between groups of our nodes, there is a quorum system built into the cluster that will effectively not let the cluster do anything unless it achieves a quorum of cluster nodes. So isolated nodes or sets of nodes are not allowed to diverge from the main cluster data source. So that's a really high-level overview. Now some questions that we typically get about XtraDB Cluster. What about replication? Well, yes, you can do standard MySQL replication. You can do it into or out of the cluster. So if you have, again, our 3-node cluster example, you can have a master standalone MySQL server somewhere else replicating into it, and you can also have a slave replicating out from it. It's kind of similar to how MySQL cluster does replication where you really have to pick a node within that cluster to be either a slave of something else or a master to something else. It doesn't have a lot of bulletproof features to do failover and high availability for that type of replication, but it is possible to do. The XtraDB cluster is write scalable to a point. It doesn't, of course, scale infinitely. Remember, all the writes are going everywhere. It's not partitioned internally or anything like that. So it's write scalable at least for the reason that all the SQL parsing doesn't have to happen everywhere. So in our tests, we see good scalability up to 5, 6, something like that nodes. So it gives you some amount of write scalability. All the writes still hold on the nodes, so we can't scale forever. LAN or WAN architectures is actually perfectly viable with this setup. If you set up cluster nodes across a WAN, you can expect that your write latency is going to be increased to approximately a single packet round trip time to whatever the farthest node is. And again, using our 3-node setup, we could simply have multiple co-locations where our nodes are spread across all of them. There is support for MyISAM, although it's experimental. That just went out in the last release. There's a whole big list of caveats about how MyISAM works and so forth. XtraDB Cluster and Galera really were designed and built for Innodb specifically. The fact that MyISAM is non-transactional and so forth really makes it difficult to sort of wedge into this model. So MyISAM is possible, but if you were going to use it for anything but a 99% Innodb setup, I would probably try to caution you against that. It's really designed for that type of setup. So that's the sort of polished, frequently asked questions. What do you really want to know? What you really want to know is it production worthy? And that is a perfectly valid question to ask. Here's what I can tell you. There are several production users of Galera. They're not lists that we can give out in public just because we don't have permission to do so, but there are production users out there that we are aware of. We are looking for more early adopters to gain experience. I mean, I don't think that's any big secret. This is a relatively new product. It just went GA at the conference in April, and we're putting our weight behind it because we feel like it's a really sound product. It makes a lot of sense for a lot of use cases for the types of use of MySQL and sort of standard master-slave setups that we see today. And the other thing to note is that Galera actually itself is several years old already. It's not like this is a new product. It hasn't been written in the last 6 months. It's been around for a while, and it's at version 2.0, although I know that doesn't necessarily mean much these days. So I guess another question that's really important to make sure you're aware of is, are there limitations to using Galera? There are limitations to using Galera. You can find them here on the Codership Wiki, and these will be available. These slides and links will be available. To me, when I read that list, I don't see a lot of things that concern me. It's more, edge case type stuff, little nitpicky type stuff. I didn't personally see anything on that list that I felt like was a showstopper for the majority of use cases. So that's an overview of XtraDB Cluster, what it is, where it's at. Now let's talk a little bit about how we're going to configure this thing. So first of all, the replication between the cluster nodes is something you should at least have some understanding of. So there's a variable called WSRep provider options, and this variable, its job is to, it's actually a semicolon separated list of a bunch of other sub parameters, and this sends a bunch of options to the Galera library that does the actual cluster communication. So the replication between the nodes is configured within this one variable, and it actually can be on a separate network from MySQL-D, so the port and the IP that it binds to, that can actually be configured independently. It's not standard MySQL client 3306 protocol. It's its own protocol. The default port for it is 4567 on TCP. And but it actually also does support UDP and multicast if that is something that makes sense for your environment. In TCP, it does also support SSL. And I think the thing to understand about configuring and setting up the cluster is that when a node starts up, it just needs to know how to get to one other node that's already up in the cluster. If you're connecting to a running, functioning cluster, the node that's starting up and connecting just needs to know how to get to one of them. That's all it needs to know. So with that in mind, let's look at some of the actual settings. So the essential bare minimum settings that you need to have for Galera to run, we're starting off in the MySQL safe section and with a variable called WSRep URLs. And if you played with Galera or XtraDB Cluster in previous versions, you may not have seen this. This is new, but it's effectively just a list of possible cluster or nodes that might be in the cluster. And it'll just go through those and try to find one that's alive, and then it'll, if it finds one, it will connect to that, and then the node will join the cluster. I'll talk a little bit more about this in a bit. And then in the MySQL section, we have the WSRep provider. This is just a path to the libgalera library.so. We provide a cluster name, so a node will not join a cluster that has a different name, just for sanity and safety. We give the node its own name. We set something called an SST method. This is how nodes are synchronized, and I'll talk a little bit more about SSTs later. Then, after we get out of WSRep settings, we go into standard MySQL settings. We have to set row-based replication for the binlog format. We have to set Innodb auto-inc lock mode equal to 2. And then this mode, locks unsafe for binlog, used to be a requirement. Actually, now it's not, but I was told by the Codership guys that this is recommended for performance. So you should set locks unsafe for binlog equal to 1. So this is really it. You can start up a cluster node with just these settings. WSRep, just in case anybody is curious, stands for work set replication, I believe. So that's where that name came from. And everything in show variables and also show global status that has to do with Galera is prefixed by WSRep. There are some other Galera settings that you may want to be aware of. In the MySQL section, again, where the WSRep provider options already talked about, you don't actually have to configure anything in there unless you're doing, you're changing the replication IP that you're listening on or something like that, or tuning some options about quorum or cluster timeouts and things like that. But that is an option you should be aware of. Here's an example of how you would set it. Provider options is Gcache size. I'm not going to go into what Gcache is right now, but there's a whole list of things that you can tune in there, and you may, you may want to at least be familiar with that or read down through that. But they aren't required to just get a basic thing set up and running. WSRep node address. This is, as far as I know, and as far as I can tell from the documentation, this is not actually used yet, but this will be used fairly soon in the future. This is meant to be to tell the cluster the IP address that the node is listening on for MySQL connections. So this might be different from the replication port. And ultimately in the future, Galera, I believe, is going to have a setting or some feature that will allow you to ask the cluster, given cluster node, for a list of all of the available nodes, and this setting will likely be used for that, to populate that. Let's see, slave threads. There is actual parallel replication inside of Galera. But you do configure a certain number of threads to be able to write in parallel, and then if those are occupied, then it queues a little bit. So you can't. This is tunable, but the replication application of transactions can be done in parallel. Other things you might see or need to be aware of: WSRep cluster address. This is actually, and you may have seen this if you played with Galera before. This is another way to tell a node how to connect to the cluster. So this just needs to be, again, a cluster node that already is a member of the cluster. This can only be one, whereas WSRep URLs can be a list. So I find WSRep URLs a little more convenient. WSRep notify command. This is effectively just a shell script or any program on the command line that will run when the state in the cluster changes. So you can set it up to send you an email or maybe update a monitoring system or something like that. That's the notify command. And then WSRep on is kind of like the equivalent of SQL logvin. It gives you the ability to turn on and off replication at a given node for a session. I don't know of any sort of practical production use for this yet, but it's a pretty handy way to break the cluster if you want to see what happens when inconsistencies exist between the nodes and you try to replicate across that. I used it for testing. And there's a whole bunch more. You can find them, again, on Codership's wiki page that has all the documentation on all the settings, but these last two pages are the ones that I would consider to be the most important. about the idea of taking a bunch of Innodb nodes and you're doing synchronous replication to all of them, so all the writes are everywhere on commit, then you might not be as concerned about single node durability action commit. I think it's really a question how likely you think it is that all of your cluster nodes are going to lose power at the same time. There's sort of an internal disagreement that I've had with some people about how likely this is or isn't. I used to work at Yahoo, and we considered this very likely if it was all in the same data center, like data centers going offline or chunks of data centers going offline is pretty likely. But really it's about your comfort level. If this was spread across multiple WANs, then it doesn't. The likelihood of a power outage going across all these may be at your level, your desired level of acceptable data loss. Some other possibilities of things you might want to disable if you're not using replication at all, standard replication, get rid of all this stuff because it's just adding overhead to each individual server and each write that's happening. And also, if you think about some of the settings that are available for Innodb, protection against data corruption in Innodb and things like that, you might maybe want to turn some of those off. So things like double write buffer you might want to disable. Is that a recommended setting? I would say probably not, but it's something you could do if you really needed to squeeze more performance out of a cluster. So all that being said, just show us a darn configuration so we can see what it looks like. And here's an example of a working configuration. So again, we have our MySQL dsafe with our WSRep URLs. This is actually a comma-separated list of GCOM URLs that give the IP address and the port number. The port number does have to be specified even if it's a default. And then note that there's this special one on line 5, the GCOM//. This is, so the URLs are actually checked one at a time in order. And if it doesn't find any nodes, then it goes, or if it tries to connect to one and it can't get, it'll try the next one. So if it gets to a GCOM//, then it will actually form a new cluster by itself without connecting to an existing node. In the MySQL D section, again, we see the basic settings that we asked for, or we said were required: bin log format, the WSRep cluster and node, and all those settings. You can kind of see going down through here. We're using the extra backup SST method. Again, more on that later. We're doing 2 slave threads right now, although that's something to tune. I'm not going to get into that too much. And then our required Innodb settings, and then anything else we might want to set on the server via Innodb or just default server tuning settings. So that's configuration in a nutshell for XtraDB cluster. So let's move on to converting. How do we convert from regular MySQL into XtraDB cluster? So we finally need to talk about SST and what that is and what it means before we can kind of understand some of the methods. So SST stands for State Snapshot Transfer. That is a full data copy to a needy node, a node that needs a copy of the data. And again, remember, all of the data is on all of the nodes. So if we bring a new node into the cluster, or if some node gets out of sync, it needs a full copy to get back in sync with the cluster. There's various methods that are supported for SSTs. As we saw before, there's a setting for it. These are the current ones that I'm aware of, so rsync or rsync WAN, MySQL dump, or extra backup. And then there's also a special case called skip that I'll cover in a slide or two. The SST is actually fully pluggable. It's really just another command line, scriptable type interface with just command line options coming in. So you can write your own and adapt them. One example of one that I'm sure will come up eventually is the ability to do an encrypted SST. So none of the methods right now that I'm aware of can do encrypted SSTs, but it should actually be pretty easy to set up and write our own. And I'm sure as soon as we have a customer who asks for it, we'll end up doing it. So when an SST happens, let's just say it's a new node connecting to the cluster. A donor node is chosen out of the cluster as the SST source. The SST donation itself may block the donor. So if you think about what it takes to rsync an existing MySQL node to create a new node, like to build a slave or something like that, you've basically got to take the server down for that to happen. And so there may be some blocking that happens on that specific node. It is possible to configure a dedicated donor. So you can actually specify, okay, this node is always the donation node, when new nodes come online. So when does the SST happen? Well, it happens when new cluster nodes join. They get SST'd automatically. So let's look at briefly what that looks like. We have our 3-node cluster again at the top, and we have our blank node down at the bottom that's joining the cluster. So step 1, it joins the cluster, connects to one of the nodes. It doesn't matter which one. I'm connecting to the lower left. It comes into the cluster. They say, okay, great, you need an SST. Step 2, they elect a donor node, which is the node on the right, arbitrarily unless it's actually assigned. And then step 3 is that the data is transferred to the new node. So that donor node syncs all of its data over to the new node. Once that's done, then the new node joins the cluster. Pretty straightforward. If there are actual node inconsistencies inside of the cluster, so one node experiences a replication error, something like you would see with a standard replication error today, some incompatibility on the slave that you can't apply a write to, that type of inconsistency will actually trigger an SST. So the cluster in that way is self-healing. If a node gets out of sync for some weird reason, corruption, something like that, then it'll fix itself via SST. If a node does experience a brief outage, it doesn't need to do a full SST, a full state copy. Instead, it does an incremental state transfer, which is the IST. So I'm not going to go into a lot of detail about how the mechanism works, but just know that that does exist, and you don't have to do full SSTs all the time. So now we understand SSTs. Where are we going from here? Well, how do we get a single node and convert it from standalone MySQL into XtraDB Cluster? So we're going to stop MySQL. We're going to simply replace the packages for MySQL. So there are a parallel set of packages for XtraDB Cluster for the client, the server, the shared libraries, and so forth. So you just replace all those packages. We are going to add our essential Galera settings that we already talked about, including the gcom // So we're going to form a new cluster by itself, and we basically just start that guy back up, and boom, you've got a one-node cluster that is running the XtraDB Cluster software. So a stateless, peerless node that that has no other cluster to connect to is going to go and form its own cluster when you give a gcom // with no IP address and port for it to connect to. That's a signal for it to form its own cluster and start as a baseline. So at that point, that data that's in that one specific node, whatever was there in the data directory, that is the baseline for the cluster. And then every new node that joins the cluster after that will get an SST of that baseline data and whatever's changed since then. Okay, so if you're going to upgrade a single node, it's probably easiest to do from Percona Server 5.5, and that's simply because XtraDB Cluster is Percona Server 5.5 plus Galera. So I wouldn't want to wrap in a full MySQL, a major MySQL version upgrade at the same time I was moving to XtraDB Cluster. So if you're upgrading from 5.1 or 5.0, you may want to move to 5.5 first, standalone, and then take the jump into XtraDB Cluster. But in theory, at least, it should be, there should be no issue with doing that. So that's method 1, single node cut over. We know how to make one node a cluster of it with itself. So method 2, how do we change over an actual environment with masters and existing slaves? So assuming we can take some downtime, then we can go and change these all at once fairly quickly and without having to do a full SST. So let me explain. We would take our environment. We will stop all writes to it. So we want to shut down our application, do whatever we need to do there. We want to stop all of our nodes, but we want to wait until replication is synchronized and caught up between the master and any slaves we have. We're also assuming at this point that our slaves are in sync with our master, which may or may not be the case. You may want to validate that with PT table checksum from the Percona toolkit. But we're just, for the purposes of this, we're assuming that they are perfectly identical at that point in time. We want to hobble replication. We don't want replication to come back up on any of these, so we're going to either do skip slave start, do a reset slave on the slaves, whatever it is to just basically make sure that when these nodes restart, they don't come up and try to reestablish standard MySQL replication again. We start up our first node, so let's just say it's the master. The old master, we start that up just like we did on the previous slide, form the initial cluster with the gcom //, and then we're going to go start up the other guys, point them at the existing node that is up, and we're going to use SST mode skip, and that's where this skip comes from. So what we're doing here is we're saying we know that these servers are already synchronized with each other, so we're not going to waste the time to do the full SST. We're just going to skip the SST and assume that they're all starting at the same point. And remember, there's no writes happening anywhere on any of these nodes at this point, so we know it's in a consistent state. And hopefully we validated everything's consistent. So we started up with skip. We go from there, and then as we add the slaves into the cluster, they just join up and they skip the SST step. And then after we're all done and we've finished our migration, we want to probably change our SST mode to not be skipped, so then the cluster can heal itself when it needs to and do SSTs normally. So that's just a blanket changeover. Probably not appropriate for a production environment unless you want to take a downtime window. I mean, certainly this process actually should be pretty quick because you don't have to do a full SST. But if you want to, what about if you want to gradually introduce this XtraDB cluster software into your production environment so you can test it more fully? That leads us to method number 3, and that is setting up something called a slave cluster. So in this case, we can do it with no downtime. Similar to the previous method, we just but we form a cluster with one of the slaves. And we, so it's a standalone cluster, one node, and we leave that slave as still as connected to the master, doing standard MySQL replication out of the existing regular master into this one node cluster. So basically, it's just a standalone slave, just like anything else. So when we do that, though, we have to be careful that we set log slave updates on that node. Otherwise, the data coming in from replication will not actually end up getting applied to any other cluster nodes underneath it. So just be aware of that. So we do that, and once we have it up and running, then we just go and test it like any other slave. So if you've ever done an upgrade where you've gone from maybe from 5.0 or 5.1 to 5.5, where you've updated a slave at a time, and you update one slave, you put it in rotation, make sure everything looks good on the and the replication runs well, the application can read from it, things it's just in your load balancer pool for reads. You're just validating and testing that the thing seems robust. This is a great way to introduce it into your environment. Once you start to get a little more comfortable with it, you can start moving more slaves out of your standard slave environment into the cluster as cluster members. And remember, that one node is replicating from the existing master. All the writes after that are synchronous to the rest of the cluster. So you can just read off of all of those nodes that are in the cluster. And again, as you're building confidence, you're trying to make sure that this is stable, it's acting good with your workload and in your environment. And then at some point, when you're comfortable with it, you just go ahead and cut writes over to the cluster. So instead of writing to your old standalone MySQL master, you instead start writing to the cluster. And once that happens, you can do whatever you need to do with the master. Just make it another cluster node or do whatever, and then you've migrated over with next to zero downtime except for the minor time it took to do the switch of where the writes go. So in this case, you probably don't want to use the skip SST, because it would be pretty difficult to take a slave that's replicating from the old master and sort of quiesce writes, make sure that it's the same as whatever's in the cluster, and then do a skip. It's probably a lot easier just to take the slave, let it recopy everything, and be good. There might be ways around that, but probably not without at least some downtime. So I guess what I would put forth here is say, don't be afraid of SST. We want SST to work right, and you want to test SST to make sure it works the way you expect it to. So don't be afraid of SST. Let it happen. It's automated. It's the thing we've been basically waiting for a long time. So that is migrating, how the methods I'm proposing anyway that we could migrate to XtraDB cluster. So let's talk a little bit about operations. How can we manage this system? How can we monitor it? So monitoring first. First of all, show global status like WSRep. We can see all the status variables that Galera provides. There's quite a few. We want to check a handful of things. And at the first level, we want to check the cluster as a whole. So the cluster integrity, some things to check across all the nodes that they're in sync and they make sense. There's something called the configuration ID, the conf ID. This is effectively the internal configuration of all the sort of known nodes in the cluster. So every time a node joins or drops off, the cluster conf ID effectively just an auto increment, so it increments and you can see that state change. We want to make sure that's the same everywhere. It should be. That's what the cluster is supposed to do. The cluster size is just the number of nodes in the cluster. Again, we're just looking for sanity checking. And then the cluster status should be primary. And primary indicates that it has quorum, it has the majority of nodes, and it is accepting operations on the cluster. If it's not primary, then you've probably got trouble, a partition or something like that. At the node level, individual node level, you can monitor the WS rep ready. This is an indicator that the node is a functioning member of the cluster and that it's ready to take connections and do operations. There's the local state comment, which gives you a basic status message about, or maybe a status word about what state the node is in. So, for example, that will show donor when the node is donating to another node. Flow control paused is an indicator of replication lag. And then local send queue is an indicator of network bottlenecks. There actually are a bunch more that you can take a look at, but my source for this slide is pretty much right off of Codership's wiki about monitoring. So these are some basic things, though, that you can check and monitor. Now, the question somebody's probably asking, is there a Nagios plugin? No, there's no Nagios plugin yet that I know of. Maybe there is, but we need one, and it's only a matter of time until we get it. Same thing with cacti templates and so forth. It's really just a matter of time and some customer of ours, or maybe one of you, putting together some open source templates and Nagios plugins and so forth. What does exist today that I can show you is a tool that is part of a toolkit that I maintain called MySQL Gadgets. It's available on GitHub for free, open source. And I wrote a WS rep view into it that will basically just connect to a single node and show you a bunch of state about what's happening in that node. And I found this really handy when I was testing and experimenting with XtraDB Cluster. So you can check that out. I actually just literally rewrote or rearranged this whole thing in the last hour, but this more or less gives you a flavor for what you can see. You can see replication traffic going into and out of the node. You can see the state of the node, whether this node happened to have been a donor, and then it was synced. We can see the count is the number of nodes in the cluster and so forth. There's a lot of other things in here that I don't want to go into right now. So that's monitoring. And this is, as far as I know, the only tool available for monitoring XtraDB Cluster in any way. But there may be more that I'm unaware of. So what about maintenance? How can we do maintenance on our cluster? Well, rolling package upgrades are possible. You can actually just, anytime you want to, take a node out of the cluster, just go ahead and stop it, upgrade the software, restart it, and it'll just go back and join the cluster again. So those are actually pretty straightforward, at least at this point in time, when there's no, backward compatibility issues, and I don't know that there will be in the future. What about schema changes? Well, schema changes are always a problem, aren't they? There is still potential for blocking and schema changes. If you think about a standard MySQL replication setup where the replication is asynchronous, the potential for blocking there is on a single node. Well, now that you have synchronous replication in an entire cluster, that extends to the whole cluster. So it is still a problem. Galera does support a rolling schema upgrade feature, and it's documented here. And what this does is it isolates DDL to individual cluster nodes. But that's good to a point until you break the DDL compatibility for replication across the nodes. And then once that happens, then you're stuck, and your solution is PT Online schema change, or it's various cousins that do more or less the same thing. So if you're interested in that, there was a webinar on that, I think about a month ago, that has recording and so forth. But yeah, this is potentially still an issue with XtraDB Cluster. It kind of remains to be seen how much of an issue it is and how well PT Online schema change works across the cluster. It does work, I've tested it, but operationally, we're gaining more experience there all the time. Architecture, how many nodes should be in our cluster? Well, if you think about a cluster, if we need to achieve quorum, then we can't do it with 2 nodes. And the quote, I believe, from the Galera guys was 50% is not a quorum. So we need at least 3 nodes, and maybe we always need odd number of nodes, perhaps, depending on how the different ways that things could possibly get network partitioned. But we want to ensure that quorum can always be achieved, so we're never split-brained. We always want the majority cluster to win, and the other guy to know that he should not take any rights and not diverge, and so we don't have 2 divergent databases. If you don't want to run 3 nodes or an odd number of nodes, because you just don't want to buy another server to run it. There's a sort of intermediate solution called garbd, which is the Galera arbitrator daemon. It acts as a voting node in the for the quorum in the cluster. It doesn't store data. It doesn't run MySQL, so there's no any disk storage, but it does actually replicate all the data. So that's an option that you could potentially use if you maybe have a 2-node setup, or you actually have a 2 co-location setup. I've actually talked to a few customers in the last couple weeks that are evaluating HAProxy cluster, and one of the concerns, maybe not concerns, but one of the things that they need to figure out a workaround for is they only have 2 data centers, and they want to have that quorum, they want to have that auto failover, so they need to figure out where they're going to put their arbitrator or extra nodes. What gear should you get for XtraDB cluster? Well, think about it in the terms of synchronous replication. Writes are only going to go as fast as your slowest node. So if you cheap out on the hardware for some of your nodes, that's going to potentially slow down the rest of your cluster. Beyond that, though, it's pretty much just standard MySQL plus Innodb choices. RAID with battery back write cache, lots of RAM and so forth. I mean, these are all sort of standard discussions that happen elsewhere. There's really nothing else special you need to worry about. Now, one potential option for something like garbd, if you're going to do a node that was just for garbd, is that you could run it on a cloud server, or potentially just an underpowered server. And that wouldn't have to have all the disks, any kind of RAID or anything like that, but it would have to have a decent network pipe and probably a reasonable CPU, just so that, because it does get all that replication traffic. So if we look at an architecture with garbd, say in cloud, just as an example, we have our 2 MySQL nodes in Colo 1 and Colo 2, and then we throw up an EC2 instance running garbd. And that might be a reasonable way for you to get that 3rd location to give you quorum in case there's split brain between your 2 data centers. So from an architecture perspective, that's likely going to get some heavy use, garbd. So that's operations. Last section. I think last section, yes. Let's talk about application and cluster interactions. How are they going to work together? Let's talk a little bit first, though, about synchronous writes and how they actually look inside the cluster. So when you do a write in the cluster, you're connected to a node, and I'm going to call that the source node for the purposes of this. It could be any node. And within that node, there's pessimistic locking, which isn't anything magical. It's just standard Innodb transaction locking, which goes out and locks everything first. And then once it's got its lock on everything that it thinks it needs, then it goes and does the commit. And at that point, the commit usually just applies in single node Innodb. So that's pessimistic locking within the single node. And then when XtraDB cluster goes to replicate that, on commit, what happens is before the source returns commit, it's something called optimistic locking, which is sort of firing out that transaction, just saying, hey, can you guys all do this? Is that cool? And then just waiting for a response. So the source node, before the commit returns, it fires that out to certify the transaction on all of the other nodes. And then the nodes will either accept or reject based on whether or not they have any locking conflicts with that transaction. So if there's any other transaction on that node, for example, that has a lock that our transaction needs, then that's a locking conflict. And then what happens is that our whole transaction rolls back and gets a deadlock error at commit, which is unusual in Innodb. So it's something to be aware of for your application. If the commit succeeds on all of the nodes, then the client gets a normal commit back and everybody's happy. So that's sort of optimistic, pessimistic. To give you an illustration of how that works, we have our 3-node cluster. Again, that's our circles. We have a client connecting to our transaction source up at the top, doing an update on one specific row. And it goes out to certify that transaction right at commit. It goes out to certify. It gets accepted on one, but it fails on the other guy because the other guy has another client connected trying to do something on the same row. Then the whole thing gets rolled back in that case. And the other guy, who may have gotten there later, actually gets to go ahead. So that is a reality of how this replication works. It's optimistic locking across the cluster. We don't go lock everything on every node everywhere before we commit. So because of that, why do we care? Well, it's really workload dependent. But if you write to all the nodes in the cluster simultaneously and evenly, so you just have a load balancer with a standard load balancing algorithm across the nodes, then what's going to happen is you may get an increase of deadlock errors on hotspots inside your data. And by hotspot, I mean a chunk of data, maybe it's a small table or some specific rows that you're always updating all the time from a lot of different clients. If that's spread across the cluster, you're probably going to see an increase of deadlocks there. So what can we do about that? Well, it's actually fairly straightforward. We can avoid it just by running to a node at a time. And what that does is it puts all the pessimistic locking onto one node. So it's sort of standard Innodb then at that point. We have one node that's one chunk of data that's contentious, but we're doing all the locking for it in one place, so therefore we don't have to worry about the optimistic locking failing and issuing a rollback. So if we didn't want to just isolate our writes to one node, we can divide our data if our data is logically divided into subsets, we could split those out into separate nodes. And so, for example, if we had different databases that didn't interact with each other, tables, rows, et cetera, some kind of logical partitioning across our full data set, then we could basically assign different nodes to handle writes for different data sets if that made sense to do. And then effectively there we're just saying, well, we're just subdividing the data set, but we're still isolating the pessimistic locking for that subset to a specific node, and they just might be different nodes. So that's something to be aware of. Is that going to affect your application? Remember, bullet point number one, it's workload dependent. It may or may not, but it is something to be aware of. The application, so when we actually connect to the cluster, how should we do it? Well, for writes, the best practice we're going to put out there is that it should just be any single node. And as long as that node is up in a functioning member of the cluster, then go ahead and write to it, and that's fine. But pick one of them and don't spread it across all of them. Is that the only practice? Not necessarily, but it's probably going to be the best practice for a smooth migration. For reads is a much better story. Just load balance all the nodes, no problem. Now we can certainly hash to hit hot caches, so we can, if we have certain nodes that are dedicated for certain types of read workloads, we can take better advantage of hot caches in that case, and that's perfectly fine. We can do geo-affinity if we have WAN setups, right? We don't want to read from a remote node if we've got one locally. All those things we can do, but fundamentally we're still able to use all of our nodes for reads because we don't have to worry about replication delay anymore. We don't have to worry about lag. Everything's synchronously replicated. So that's one of the awesome things about this is like, wow, I don't have to worry about consistent reads and overloading my master because I don't know if what I just wrote in the master made it to the slave or not yet. So it's really a good thing. So the whole point here, though, is that we need to monitor that the nodes are a functioning member of our cluster. We need to be careful about how we load balance traffic to our cluster nodes. So that being said, how do we do that? Just to give an example, our 3-node cluster, we've got some load balancers. They're set up in front for redundancy. There's a couple of them, and our clients just connect to there for reads and writes, and our load balancers do the rest of the work. So what do we need to check? Well, we need to health check our port, make sure that MySQL is up and running. That's sort of the obvious thing. But beyond that, we probably want to be a little more intelligent and understand something about the node status. So we want to make sure that the WS rep ready is on. That means that the node is a functioning member of the primary cluster. And we also may want to check and make sure that the node isn't a donor, because donation does block to some extent, depending on the method. Maybe we just want to keep that out of rotation, and that's perfectly easy to do with modern load balancing technology. So we still may want to maintain separate rotations for reads versus writes. So for reads, we just do a round robin or at least connected of all of them that are available. And then for writes, we do a single node with backups on failure. So it doesn't matter which node as long as there's a single node for our best practices. What technologies work good with this? Well, there is a GLBD, which is a Galera load balancer. The Galera guys actually put it out, the Codership guys. This is similar to Pen. It can utilize multiple cores if you're familiar with that. But as far as I'm aware, it doesn't do any advanced health checking. It just does a pretty standard TCP 3306 port check. So documentation for it's here. You can go check it out. I wouldn't be surprised if we could convince the Codership guys to improve this guy. But that's what's out there. Another perfectly viable alternative, I think, is HAProxy, which I'm actually just getting up to speed on, but it's pretty awesome. And with HAProxy, we can do something like an HTTP check, which seems non-intuitive, but we can do that to check our own sort of custom web server that will actually go and check the node status for us and then return a result based on on the state of the actual MySQL node. So it's sort of a layer 7 kind of check. There's some documentation in the XtraDB cluster doc that covers that and how you can set it up. So if we're going to set up HAProxy, what might a configuration look like? Like this is a good example. Now, I've been told by some HAProxy expert that using listen is bad form, but to be honest, I think it looks a lot cleaner than front-end, back-end stuff, at least for TCP. But we have two different ports that we are setting up for writes, one for writes and one for reads, 4306 and 5306, just as an example. We're doing least connected, we're doing our HTTP check. All of our servers are doing check port 9200, which is our crude HTTP server that's basically just doing a node local check on the show global status variables. And the only real difference between the writes and the reads is that for the writes, our second and third server are specified as backup servers. So only the first server is up, and then if that fails, it'll go to the next one. If that fails, it goes to the next one. And then for reads, it's just all up and load balancing across all of them. So that's HAProxy. So with that, we are right about at time, and here's my resources page. The XtraDB cluster homepage and documentation you can find here at Percona.com. The Galera documentation, which is probably where you're going to find a lot of the nuts and bolts for the settings and the global status variables and so forth, can be found here. If you want to experiment with XtraDB cluster yourself using VirtualBox and Vagrant, Vagrant is the bomb, you can find my copy of something that Fred DeCamp wrote. I'll give him full credit, but I took it and modified it. It actually has an HAProxy configuration in it as well, and some other things that I was experimenting with. But this is Fred's original post about using Vagrant and setting up XtraDB cluster from his GitHub repository that I forked. And then beyond that, Vadim has written a post a while back about a shell script that he wrote to fire up nodes in EC2 instances just to very rapidly. So he's got a shell script that will basically roll them up pretty quickly. So you might want to check that out, again, for experimentation purposes. So with that, that is all I've got for today. So I will be happy to take questions if anybody's got any.
Okay, Jay, we have quite a few questions. So the first one we have is, how do you deal with quorum and failure detection across the multiple remote locations?
Okay. So it's really the same whether it's WAN or not, in the sense that you've got to have a quorum of nodes. Galera doesn't care that the nodes are further away or not for the most part. Like, you don't specify, these nodes are in this data center and these are in this data center. There's no sort of intelligence about that. They all just talk to each other. So the only real concern that you have to have in setting up a WAN environment, and there's some documentation on this in the codership region, is you may have to configure some of the TTLs and other timeouts for node freshness checks and aliveness checks somewhat when you go into a WAN environment. But beyond that, it's pretty much the same as a LAN environment. All the nodes all talk to each other. There's no consolidation of traffic across WAN links. It's all to all nodes.
Okay, next question regarding write scalability. If all writes are propagated to all nodes, it doesn't seem to save lots of IOPS, or does the group commit effect help a lot?
I can't speak for group commit. The basic win, in my understanding, is that what you're saving is SQL parsing and that the CPU overhead of that. From an IOP perspective, yes, all the data is all being stored on all the nodes. So fundamentally, yes, you're doing all the IOPS. Would group commit help with that? That's a good question. I don't know the answer to it.
Okay. Next question. Can we add a set of clusters as slaves of already running production without downtime?
Yeah, basically the method that I showed, method number 3 about setting up a slave cluster from an existing master-slave environment is actually pretty straightforward and easy to do. You take that one slave, you convert it to a cluster, you add some more nodes to it, and you leave it replicating from that existing master. So there's no, there's nothing that's preventing that from happening as long as everything's configured properly. I will sort of reinforce the notion that while that seems like a really great idea, I'm not sure I would want to do it on a long-term setup because there's no HA built into failing over replication into or out of the cluster. So if you are connected, let's say you have one node that is acting as a slave to some other MySQL master. If that one node fails, then your cluster is now, you're not sure where to connect to on that master. And there's no sort of mechanism at the moment to make that really easy. Likewise, if you are slaving off of a cluster, same thing. Whatever node you connect to slave from, if that node goes down, you can't assume that the bin log positions are the same on all the other cluster nodes, because they won't be. So we're having some discussions now with the Codership guys about some ideas about how to address at least the second one. I think it would be great for migration, but not necessarily something you want in production, although I do have a customer who is asking about it right now. So.
Okay, next question. How do we take the very first SST from the running master? Does it require taking the master down?
If you take an SST, well, it depends on the method, first of all. So if you use XtraBackup as your SST method, you can, or actually even MySQL dump in theory, you can keep that node running for the most of the SST. There is a certain point, even with XtraBackup, right toward the end, where it does have to do a quick block and it finishes up the XtraBackup copy. So I think understanding how long an SST is going to take and the potential impact to your production environment is really going to influence, in my opinion, which of the methods you choose in that section I talked about. Migrating, whether you're going to take the whole cluster down at once, or whether or not you're going to start with a slave cluster. You want to be careful about how you do that, so you're planning forward and know you don't have to take any potential downtime, or you don't want to add the load to that single master that's the cluster of even XtraBackup, because maybe it's really, really busy. So I would say, the original question. So read me the original question again, Terry, so make sure I answer it.
How do you take the very first SST from the running master? Does it require taking the master down?
Yeah. So if you're going to do an SST and you can't sort of take two servers that are already in sync from standard replication and do a skip SST, then you must run a full SST to get that copy over. There are some trickery ways to get a copy and sort of do your own SST. I'm not sure that it buys you a lot, but in general, the answer is you can't do it without blocking that master if you have to do a real SST, although it might just be a little bit of a blocking.
Okay. Next question. What's the implication for client library? We're using Ruby on Rails 3 with MySQL 2 gem. Do we need to write a wrapper on top of it?
I think the answer to that is going to depend on if you're going to end up using something like HAProxy as an intermediary. I think you want to have something that is going to be able to intelligently health check your cluster. So, I mean, my recommendation would be something like HAProxy. But if that's the case, then that's really just a TCP port that your application is connecting to. So for the most part, you shouldn't have to do a whole lot different. The client protocol is all the same. Nothing's been touched there. It's still just, Percona server, MySQL server client. Now, you may want to incorporate something in your application library to deal better with deadlocks. The deadlock case that I described, if you write to multiple nodes, you might want to make sure that's up to snuff. Although I would point out that if you are using Innodb for transactions, you probably should already have that. So if you aren't handling deadlock errors and you're using Innodb, you probably should, because that's just a fact of life in transactional engines anyway. But do note that those deadlocks will happen could happen on commit, which in Innodb, if it's just standalone Innodb, is typically not the case.
Okay, next question. Once you have the cluster up and running, should you add the GCOM links to each cluster node configuration and perform a rolling reboot to make sure there are no problems if a node goes down?
That's a great question, and I neglected to point to make that very clear. So the WSREP URLs, there is no requirement that is an exhaustive list of every node in the cluster, and that does not enforce cluster membership or do anything to tell the cluster who should be joined. The only purpose of WSREP URLs and also the other variable, the WSREP, I believe, cluster address, It's only the only purpose of those guys is just to get the node connected to one of the other nodes in the cluster so it can join the cluster. Once the cluster is joined, it doesn't care about those unless the node restarts. So my recommendation would be you use WS-rep URLs, you only use the gcom// when you're first starting out, and then you get rid of it. And then you just keep that WS-rep URLs more or less up to date with all of the nodes in your cluster. But even when you keep that up to date, you don't have to restart MySQL for that to take effect. It's only applicable when MySQL restarts. So as long as you can keep that reasonably in shape, then it shouldn't matter. And some people have suggested, well, you could do a DNS round robin with that. You could do, you know, there might be other strategies, but the basic gist is that that is not, you know, assuming or enforcing cluster membership. It's just the cluster nodes talking to each other that actually makes that happen.
Okay, the next question is, what is the typical use case for XtraDB Cluster?
Typical use case for XtraDB Cluster is high availability. Really what you have is the ability to have a set of nodes that can auto-fail. It can take care of down nodes automatically. And if you, as long as you use the proper load balancing technique on top, that should be pretty darn transparent to the application. It's not going to be perfect, but you know, the clients will have to reconnect and so forth, but it's pretty darn good. So I see, to me, the big use case for XtraDB Cluster is replacing all of the, you know, master and 2 slave or master and 3 or 4 slaves or dual master and 2 slave environments that are sitting on LANs out there and getting rid of those things that have really big, ugly, complicated HA environments. Let's simplify all this stuff. Let's just put 4 nodes in a cluster and forget about it, and you know, and then also forget about having replication delay. To me, that's the big win. Now, what are people asking for? Most people I've talked to so far, they're asking for multi-WAN HA. And that's certainly a viable possibility with XtraDB Cluster. Some of the blog posts that Vadim did a few months ago on it really showed how, I mean, the speed of light is still the speed of light, but it is pretty darn efficient at replicating across WAN. I mean, it's really just about a ping round trip time. So if you can absorb, you know, full writes into your application, and that's not a problem, it's a great solution for that. But do remember the quorum requirements, you know, odd nodes, and that you don't just want to have 2 data centers because those could very easily get split brain between the 2. You need to have that third arbitration site, whether it's a full-blown site or whether it's just an arbitrator daemon.
Okay, next question. Can you use external information to override quorum decisions? For example, I have a pair of nodes, but I also have external knowledge of which should be disabled in case of split brain.
Yeah. So here's my understanding, and this could be slightly out of date. My understanding, first of all, you can disable quorum. So you can just tell it, well, if you can't connect to quorum, that's cool, just keep serving. Now, you want to be really careful with that because that's really easy for you know, your set of nodes to get split brain, and then you've got 2 different databases that are going to be fun to reconcile. The other thing that I heard some of the Codership guys mention at the conference was some discussion of, well, if I have, say I have 2 colos and it's 2 nodes or 3 nodes each, something like that, and it's even, can I set it up so that if it goes split brain, that I can manually select the one that wins? And I don't know where it is in the implementation stage yet, but I believe they were talking about creating some kind of node weight or something similar to basically be able to say, okay, well, if we've got 2 data centers, if one goes down, this one's going to be the winner, and he can stay up, and the other guy's going to know that he shouldn't be up. He should be offline unless he's got quorum. So I believe there was some discussion about that. I don't think that it's implemented today, but I could be wrong about that.
Okay, next question. Are there any monitoring services in Zabbix or Nagios?
Nope, not that I'm aware of. It's time for somebody to start writing them. So, you know, the monitoring slide I talked about and the monitoring documentation that the Codership guys have put out, I think serves as a good starting point, and I think it's really just up to somebody to sit down and write it. And we just haven't had the opportunity yet. I'm sure it's going to happen sooner rather than later. So it's a great open source opportunity for someone who's interested.
Okay, and last question here. Are adding or adding and updating MySQL user accounts replicated?
Yes. So grants are replicated across the cluster. My understanding, so obviously the system tables are still MyISAM. So I would believe it's the case that if you go and update those tables manually and you don't have the experimental MyISAM flag enabled, then those individual changes won't replicate. I could be wrong about that, but I believe all the standard grants do replicate.
Okay, very good. Thank you, Jay. So there are a number of questions left that we didn't have time to address.
Okay.
We'll pass those over to Jay, and he might be able to do a blog post later to try and cover some of the common questions that came up.
Yeah, sure.
We did make a recording of today's webinar, and we will also we'll put the recording as well as the slides up on a page where you can view them later, and we'll send a link to that page via email as soon as those are available to everyone who registered for today's webinar. In addition, I want to point out a couple of opportunities to interface with Percona. We will be at the Velocity Conference in Santa Clara later this month, so please stop by our booth there if you have further questions or you would like to speak with some of the other Percona professionals. And then also we'll be exhibiting at OSCON, and Jay will be there giving a talk as well. And Jay, what's the topic of your talk at OSCON?
I'm actually doing two. It's the same talks I did at the MySQL conference. It's on non-blocking programming and running a LAMP stack on a cheap VPS.
Okay, so please, if you're going to be at OSCON, stop by our booth and feel free to speak with Jay there. He'll be at the booth on and off throughout the conference. And finally, I mentioned we have tickets on sale now for Percona Live New York, which is October 1st and 2nd in New York City. We have the Super Saver rates right now, so if you are interested in going, it's a great time to save a lot of money by registering now rather than later. And we'll be announcing the dates and location of Percona Live London, which will be in November, December of this year, shortly within the next 2 weeks. So please look for that information also if you're in Europe. Thanks to everyone for attending today, and thanks, Jay, for your presentation. And we will send out the information for the webinar slides and recording shortly. Have a good day, everyone. Goodbye.